Green friend Timberlake here. I got an exciting tutorial for you today. It's tutorial day in my month of Sudoku. I'm going to be talking about alternate inference chains type 1. And now, if you're not familiar with what an alternate inference chain is you haven't looked at my videos about X chains and XY chains, I suggest you go check those out. I do a pretty good explanation and definition of those and understanding strong and weak links, and then come back to here because this builds upon the logic that you'll see in those two videos. And so in an X chain video, you're dealing with one candidate that has strong and weak links to make a chain, to make eliminations. In XY chains, you're dealing with bi-value cells, two candidates, right? And I've also done the remote pair, which is two of the same bi-value candidates in each of the cells that you try to match up. What we're doing with this alternate inference chain is I'm going to emphasize cells that have two or more candidates remaining, including bi-value cells. And this is really powerful technique. When you get hard stuck on a puzzle where you think there's no logical way to solve, this is the next step you want to do. So with that, it's solving time. For our first example, this is Sailfish by PatheticPancreas. I'll put a link to the original video below. Awesome, very fun solve, but required an alternate inference chain for me to make a lot of progress. It was a very tough Sudoku. And so when do you start looking for alternate inference chains? Well, you'll want to exhaust all the normal 1 and 2 cell logic. So you want to look at normal things like XY wings, hidden pairs, pointing pairs, even XY chains, W wings, those kind of things. And if you're still stuck, then you can consider doing an alternate inference chain. And the reason being is you want to narrow down the candidates as much as possible because these take, and will add at least 10 minutes to your solve. And they're harder to spot, it's harder to go through. It's just like another level of complexity added to your solve. So I went through, did as much as I could. You see, the only thing I could do is solve some 1s and 5. Also did a little trimming. So how do we do this? Well, I do my technique for setting myself up to spot these is what I call the Christmas lights. And so what I'll do here is highlight the candidates, and I'm going to mark whenever I see a strong link. So if there's only 2 candidates in a house, like across row 4, 2 candidates right here in column 6 and also in block 4, column 3, block 4, these 2 candidates. These 2 are across, they're locked candidates, but they're across row 5, and these 2 candidates. So all these I can mark. And I'll use a different color for each candidate. Go to 3s, same thing. Because you're trying to draw your eyes, you can see locked there, locked up here. You're trying to draw your eyes to these strong links, right? And then there's another set of strong links that I'm not going to mark, and that'd be bi-value cells. So you see this 4-3 and 5-3. They have a strong link with each other, right? This 4 is false, the 3 is true. But I'm not going to mark those because it'll kind of muddy up what I'm looking for. This is an imperfect technique. One of the things that makes it kind of imperfect, and I'll show you, is that you still have to kind of check to make sure that you're making an elimination based on only 2 in a row, column, or house. So for example, like this 4 and this 4, they are not strongly linked to each other. That 4 is strongly linked to this 4 here. This 4 is strongly linked to this 4. But don't look at these and go, this is a strong link, because it's not. And that's one of the limitations of this. 2, it also takes quite a while to set up. If you see me in the videos, I usually will show me doing the setup. The other thing is 3. Once you make an elimination, you have to kind of go through and see how it affects all your strongly links, right? So only 2 6s across there, 3 6s there, 3 6s there. There's 2 6s here, 2 6s here. So again, this is really common where you have these 2 are in strong links out to there and out to there, but this one's not part of a strong link. And then coming down, column 5. 7s. These 2 7s are strongly linked. These 2 7s are strongly linked. Okay, go to the 8s. And one of the reasons, another reason that I've done this technique, now like showing this, is that I've watched tutorials like Sudoku Swami, excellent tutorial on A1Cs or AICs type 1. I mean, that's how I learned how to do them, was watching his videos. One of the things he's great at is explaining all the different rules, variations, and where you're going to find these. But when it comes to, hey, when would you look for it and spot it in a puzzle, he doesn't really do that. He does one puzzle where he solves, where he uses, most very advanced strategies like an AIC, but he'd already like solved it. And he just kind of runs through. He doesn't do the discovery part, which is what I'm going to show you here. The kind of, what am I looking for and how am I going to find it? All right, the last thing I'll do, if I marked all the ones I believe were strong links, is I'll go to highlight all the bi-value cells. And the reason being is some of these bi-value cells, like right here, it doesn't have any colors. The ones that do have colors, these are good. These are cells you want to consider, because what it means is there's a strong link coming out of here. So I can go strong, weak, and look for another strong candidate. So again, I can't go up here with the strong. Or I can go, strong, or come back in here, right? Strong, weak, and now I'm going to try to position the 3 somewhere. So those are ones you want to look out for. So I have the bi-value cells because those can be start or end points. I have all the colors. Something else you'll notice when you're doing this is if you missed a hidden pair, you'll be able to catch them. So like how this 5 and the 8, there's only 2 5s and 2 8s. If they were mixed up with a bunch of other cells, you could tell it's a hidden pair because they both have strong links. So sometimes I will catch hidden pairs by doing this coloring method. It's kind of nice. So let's get in here and how we're going to find our alternate inference chain that can lead to eliminations. So how do you start looking for these things? Well, you're going to start with the strong links and work between strong and weak links, right? And remember, a strong link can also be a surrogate weak link. I try to tend to look for candidates that have a lot of the strong links. So like the 9, the 9s, that's a good one. The 8s are a good one. The 5s are a good one. Those all seem to have a decent amount of cells that I can use. And so there's an A1C and an AIC, and I'll show it to you right here to kind of see how it works. All right. I also like to kind of mark the start and end cell. I usually mark the start and then kind of see where I go. So my idea is I'm starting here with this 9. Like I want to be able to eliminate maybe some of these 9s here in block 8. Is there another 9 I can connect with to do that? So I could connect with this 9 or this 9. So we'll try to connect to this 9 and we'd be able to eliminate these 9s right here. So way to do this. We have a strong link from the 9 to this 9, right? And then we have a weak link to this 2. So we don't care about the 3 and the 7. We have a weak link to this 2. Strong to that 2. Weak to this 8 because it's within the cell. Strong to this 8. Weak to this 8. Strong to this 8. Okay? Weak to this 8. We can cut all the way across here. Weak, right? Even though there's an 8 there, it's a weak link. It's okay. Strong to this 8. Okay? Weak to this 8. Strong to this 8. All right. And then weak to this 9. Strong to that 9. And so you have to start with a strong link and end with a strong link. And by doing that, we've used all 2 or more cells, strong and alternated the strong with links. We can eliminate whatever, we can eliminate 9s from whatever cells the start and end point see. So an AIC, it'll end in a different spot, or it'll end in a different house normally, and then you can make those eliminations. So we can eliminate a 9 from right there and right there. All right, so after we make this solve, something really cool I wanted to show you is that it helps us go to the next advanced technique. So what I'm going to do is I'm going to remove all the colors, and that's dangerous. You want to make sure that you have some kind of other technique to work off of before you remove all the colors. And so I'm going to remove all the colors because I want to show you, once you eliminated this 9 right here, you'll see that there is a swordfish. And again, a swordfish is also another technique I recommend that you have down before you tackle alternate inference chains. They're a little bit easier to spot. So once we eliminated that 9, Now we have a nice, good swordfish, a 3 by 3, right? So 9s have to be in one of these 3 spots in rows 2, 6, and 9. And so then you can eliminate all these other 9s. And this really opens this puzzle up tremendously, and then you can make all bunch of progress. But you had to find some way to eliminate that 9 to kind of make all this work. Now let's move on to our next puzzle. Okay, for our second example, this was the recommended puzzle by Roy the Geek, sent to me from a computer app, and it has a very cool alternate inference chain. In fact, there would be multiple alternate inference chains that we could solve using this puzzle. In fact, I could kind of show some of those off, but I wanted to focus on the one that will cause the most eliminations and actually lead to a solve. So I already set up the Christmas lights, and a couple things I wanted to point out here too is let's look at the 7s and the 8s. So you see these 7s, right? The 7s, there's 2 here, there's 2 there. They make a square in this area, and they're linked to these 8s, but the 8s are right here. There's no other cells that connect to those. Like there's no other 8s or 7s that you can connect to, right? They just connect to each other. So I call these closed loop candidates. And what that means is you can pretty much ignore them when it comes to solving, because they're not, you need one of these to be able to link up with another strong candidate in that cell. Or one of these would need to be in a by-value cell with something else. But since these 2 are together and they're a pair, you'll never, strong, weak, strong, weak, strong, weak. Like you'll never get out. And then if you go weak to one of these are weakly linked to the other cells in that house. So you can't do 2 weak links. So I want to point that out. Another thing I'd point out is what I call kind of like carrier cells. So those are the ones that you have a lot of in the puzzle, the candidates. So carrier candidates, you have a lot of them in the puzzle, and they'll help you get around the grid. In this particular puzzle, I'd say that the 1s are pretty good carrier candidate, and so are the 6s. And so what I mean by the 1s is you can use these 1s, actually the 1s and 6s. See how the 1 weak link to this 1, strong to that 1, and you can weak link to some of these other ones. And then with the 6, you have the strong link here to 6, weak to this 4, strong to the 4. You have the strong to this 6, weak, strong, weak. And you can kind of move, strong, weak, strong, weak, strong, weak, strong. You see how you're kind of moving around with these 1s, the 6s, the 4s. This particular block, since it has the 1s that are strongly linked, the 6 is strongly linked, the 9 has a strong link coming out of it, and then the 4s, and you have 2 by-value cells. This is an important block to look at. So when you're looking for AICs, you want to see a block like this that has a lot of ways to kind of get out of the block and connect to more cells. All right, so here's where the alternate inference chain is. And what's neat about this one is that it starts with the by-value cell. So you can go right here and let's say, okay, 7 to the 2, right? So strong, and then weak to this 2, strong to this 6, which we can do because they're both a by-value cell. Weak to this 6, strong to this 6. There's only 2 6s in the house. Weak to this 1, strong to this 1. Weak to this 9, strong to this 9. Okay? Weak to this 9, and then strong to this 7. So again, we can use another strong link within the by-value cell. And so we started here with this 7, and we ended with this 7. And what's nice is now we can eliminate any 7 that those 2 cells see. So we can eliminate the 7s here, and right here. And once you eliminate a cell that's colored, or a candidate that's colored, like that 7 was colored, what you know is it's part of a strong link. So you just got to find the other part of the strong link, and you can solve for that cell. So that 7 was strongly linked to this 7. So we can solve that for a 7. And then we can solve this for a 9, and this for a 1. And then we move right along with the puzzle. But I wanted to show you that, to kind of show you how the logic works there. Okay, for our last puzzle, this is Mirror by Leyrann. Excellent puzzle. Very hard for me to solve. I had to work a long time to solve it. And I'll put a link to that in the description below. What's nice is you can look through here and see if you can, take a few seconds, maybe recreate the puzzle, see if you can find some alternate inference chains. There's quite a bit going on here. But what I wanted to do is, oh, I'll show you something else before I go and solve the key to cracking this puzzle. So let's look at the 6s here, right? We can eliminate that 6, eliminate that 6. But something you'll notice is you have 6, 6, 6, 6, and then you have this 1 right here. So the only way to get out of these 6s, you know, 6, strong to this 6, weak to that 1, strong to this 1, weak to the 2, strong to the 2, is through this 1. Realize that once you, quote unquote, get out of the 6s, you won't be able to solve for a 6 because you won't be able to get back in to where the 6s are once you leave this set of 4. Hopefully that makes sense to you, because you're never going to connect to some other, there's no link inside this 3, 9, 6, 7 that they'll be a weak, you know, they'll allow you a weak link here and then a strong. It just won't happen. So like if you're looking for alternate inference chain, you would not want to start with this 6. You wouldn't want to start with this 6 or this 6 for that reason. You're not going to be able to solve it. All right. Now, to happier news, what can we use to solve here? Well, let's put on our bi-value cells, and what you'll notice is you don't have that many bi-value cells. In fact, I only solved one cell prior to putting the alternate inference chain. So sometimes you're going to get hard stuck pretty early in a puzzle. I had made some other small changes, but made some small eliminations to like pointing pairs and some two-string kites, that kind of stuff. But again, I wasn't able to make any forward progress. So I whipped out the old Christmas lights here, and then I ended up finding the key to solving this puzzle. Now again, you can look at it for a few seconds, but then I'll show you. What we have is not just an alternate inference chain, but we have a continuous loop. And it's not just a continuous loop with with bi-value cells. So I've showed you that before with Hurricane, the one I solved by Clover. That was a continuous loop with just bi-value cells, and that was a really cool solve. I'll put a link right now. This one has to do with these cells in these 4 corners, here, 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 and here. And so I can just start in 1. And the difference between a continuous loop and a regular AIC type 1 is with a continuous loop, you're going to come back around to the start point, and it leads to a ton of eliminations. Once you find a continuous loop, you have hit the jackpot. So let's start with this 8. We could actually start in kind of any spot along here, but you're going to be using the 8s and the 2s. So this 8 has a strong link to this 2, a weak link to this 2, surrogate, strong link to this 2, weak link to this 8, strong link to this 8, and then a weak link back to this 8, right? So strong, weak, strong, weak, strong, weak. And then you keep on going, strong, and you would just keep on going. Weak. So like you can start this 2 here, strong, weak, strong, weak, strong, weak, strong. See how it works with the 2s and the 8s? What does that mean? It means that if this isn't a 2, that's a 2. If this isn't an 8, then that's an 8. If this isn't an 8, that's an 8. If this isn't, that's not an 8, it's a 2. That's not a 2. That's a 2. You know what I'm saying? So what we can do is when you find a nice continuous loop like this, you can eliminate all the other candidates in between those links. So what eliminations are we talking about here? 8, 2, strong, weak. So you go look at the weak. So you can eliminate all the other 2s along row 3. Strong, weak, strong. We know it's a strong link here, so you shouldn't be able to eliminate any other 2s. Weak to this 8, and since it was a loop, you can get rid of these cells right there. 1 or 3 can't be a solution to this cell. It has to be a 2 or an 8. Strong. Weak, strong. Right? Shouldn't be any other 8 strong there. And then weak up to this 8. And so what that means is you're eliminating any other 8. And hopefully you notice by making those eliminations, we can solve a couple cells, right? Right here. The 3 is all by itself. We can solve that for a 3. And then you can see you have a 1, 2, 8 triple along here. We eliminated a 3 from right here. So wherever that was strongly linked to, you can solve that for a 3. So that's this one right here. See how that works? Nice continuous loop. And so this was a loop that contained 2 or more candidates in each cell. And it was from, it's the logic of Alternate Inference Chain Type 1. Awesome. I loved it when I found this, and I was able to move on and solve the rest of the puzzle. So, what do you think about alternate inference chains? Is it making sense to you? Do you have a different technique or method you use to kind of find these and work your way around? Hopefully I explained some good places to start when you're trying to find those. Try the by value cells, try the strong links. Ignore any of these cells that have no colors in them because they're not going to help you out unless it's a by value cell. This 1, 3, that's fine. But like this, you're not going to make any links in or out of there, so you can ignore it. The only thing you can do is you'll make some eliminations if, say, you're in a match, a 4 with a 4 over here or something like that. Also, don't forget to come back each day in February. Check out some new videos. I got a new one each and every day. And if you can't wait that long, check out these other 2 videos from my channel. Don't forget to like, share, comment, subscribe, Smart Hobbies. Thank you all so much for watching.